Passive optical multiplexing is a very cost-effective way of combining multiple optical signals onto a fiber. But do you know what an OADM is and how it works? If you want to find out more, stick around and we'll check it out. To understand how an optical add drop multiplexer, or short OADM, works, let's first have a look at a standard dual fiber optical multiplexer. And as you can see here, we've got a schematic of a dual fiber optical multiplexer. And how it works, we've got the common port here, so the line connection, and the receiving side of that line connection is connected to an optical demultiplexer, so it will separate the different wavelengths. And then this transmit side of the common port is connected to an optical multiplexer, which combines the different wavelengths. And how we then connect all that is, well, we've got the transceiver, and the transmit side of that transceiver is then connected to the respective channel of the multiplexer, and the demultiplexer is then connected to the receive side of the transceiver. And then we carry on with multiple transceivers, all connected to the respective channel ports of the multiplexer, and that's then how we combine all these signals onto a pair of fiber. From a setup point of view, it is pretty straightforward because we've got a point-to-point connection connecting site A and site B with this optical multiplexing technology. Now, let's get to the OADM. And to explain how the OADM works, let's first have a look at the first half of an OADM. And as you will see here, this is literally an optical multiplexer, because once again we've got the common port here with the receive side of the common port connected to a demultiplexer, and the transmit side of the common port connected to a multiplexer. And then we've got the transceivers that are then connected to the multiplexer and demultiplexer. So, okay, that's the first half of an OADM. Let's look at the other half. And as you will notice, once again, we've got an optical multiplexer there. As a matter of fact, we've got a multiplexer multiplexing exactly the same channels as on this other side. So far we've got 2 times the same multiplexer in one enclosure. So, I mean, that can't be an OADM, right? Well, no, because there are 2 main differences now that actually make an OADM an OADM. And the first one being, we have got a connection here, and that connection passes through all the remaining wavelengths except for those that are being accessed here, but from west to east and also from east to west. And the other very important thing, and that's got to do with the filter design in the OADM module, is that the signals here will always only go in and out on the west side, whereas the signals on this side here will always only go in and out on the east side. So you will never have a crossing of those signals. Now, of course, we have different types of OADMs that access different wavelengths. So what is a normal use case or a common use case of OADMs? Well, we have the so-called OADM ring topology. Let me explain. So we've got 3 different sites here in this example, and we'll go one way round first. So at site A, we've got a standard multiplexer here, and we're multiplexing these 4 signals. So we've got red, green, blue, and purple. And those 4 signals are then going this way round. And then we get to site A, and we've got the OADM, which is accessing the red and the green. And as I said beforehand, the OADM passes through the remaining wavelengths. So in other words, blue and purple will pass through here and then eventually arrive at site C, where we've got the OADM, which is accessing the blue and the purple. So now let's go the other way around, because we have another optical multiplexer which is multiplexing exactly the same signals, so exactly the same wavelengths and signals, and these are then going this way round. So we're going around here, so we access the blue and the purple here at site C using OADM 2, and then green and red are passed through here, so we then arrive here at site B with the OADM 1. So in other words, if we go this way round, we've got a connection from site A to B to C. The other way round, we've got A to C to B. So now imagine that at each site we've also got switches or routers, for example. And we've got a link that is then working going from site A to B to C. And at some point we then have a fiber cut here between site B and site C. Now the switch here on site C will then realize that it hasn't got a signal anymore and can then automatically switch over to this link because it's got exactly the same link and it always has the signals coming through here. And in other words, the OADM ring is a redundancy setup and is done by using these passive OADM modules. So, I hope you learned something today and that you enjoyed this video. If so, please leave a comment. And of course, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye bye.